Recently, we've been hearing more and more about the problem of salinity in the countryside of Australia. First, it was the Murray Basin in parts of Victoria and New South Wales, and then it was part of the wheat belt of southwestern Western Australia, with major salinity problems. We now realise that the widespread clearing of land has been a major factor in increasing salinity. It is a billion-dollar problem that must be remedied. There may well be value in seeking advice from the original custodians of the land who managed it effectively over a large period of time. So the first stop point is to identify the regions of Australia with naturally saline soils, and you'll be able to do that by doing the activity that I've put on the worksheet. But here I've got some pictures here that show you some of those areas. Okay, one naturally saline area is northern South Australia and the southern Northern Territory, with lakes such as Lake Eyre, which is this one, Lake Torrens, Lake Frome, that's a cool picture, and Lake Gairdner. Parts of the Murray-Darling Basin, these lakes are the remains of a vast inland sea that once extended south from the Gulf of Carpentaria. During the dry season, many of the salt lakes became salt-encrusted swamp beds or clay pens, okay, which you can see in the images. There are parts of the Murray-Darling Basin that have naturally saline seepages and scalds. Scalds are areas where the salt has come to the surface, leaving a bare, crusty area where nothing can grow due to the high salinity. And there are also parts of southern Western Australia that have natural salt lakes. Okay, such as Dorodine Creek here. And then another image of Lake Johnson, which is a naturally formed salt lake in Great Western Woodlands of southwestern Australia. The salt lake was formed by saline groundwater approaching the ground surface. Okay. And there are parts, of southwestern Australia. So what's salinity? Salinity is a word to describe the salt content of soil or water. When the salt content is excessive, it degrades water quality and land productivity. Soluble salts are often found in water and soil, but usually not in sufficient concentrations to affect plant or animal survival, and are often, quite necessary for them. It is a growing concern around the world. Much of the world's farmland is becoming too salty for crops to tolerate. Soil salinity is associated with increased salinity in rivers. Today, scientists understand what causes these problems, but is it too late to fix the damage already caused? So, when non-Indigenous people settled on the land and cleared it for the purpose of pasture and agriculture, they used European methods of farming, unaware that these methods were basically not suitable for Australian soils. Removal of trees that take up large amounts of water and the replacement of them with shallow-rooted plants such as crops or pastures that take up very little water means that there will be more water in the soil. As this water percolates through the soil, it will add to the amount of water in the water table. This results in the water table rising and bringing the salts with it to surface. And you can check out this site that I've also put on your documents page, which you can have a look at some of the main issues around the Murray-Darling Basin. It's a useful website, and you'll find a lot of government websites regarding the salinity problem because of the major impact that farming made to Australian soils. And already, as we have discovered, Australian soils are not exactly the most fertile, but it is one of our most important resources in terms of, our economy and providing jobs, and also is our produce, whether it be live produce or wheat, grains, vegetables, fruits that we actually often are exporting as well. So, the issue of salinity is quite important. So great inland seas and inward drainage of great river basins have produced areas of naturally saline soil in Australia. For example, Lake Eyre in the southwestern wheat belt of Western Australia, which we looked at a few pictures of. It steadily increased, as I said, due to the agricultural practices that are inappropriate for our environment. For example, within the Murray-Darling Basin, the farmers there are culprits of this. And we'll quickly have a look at this example. Diverting water for irrigation purposes causes areas of river to be lower than normal and increases the water table under the regions of irrigation. The salinity rises in these areas, and if water from these areas makes its way back to the river via runoff, it increases the salinity of the entire river system. So that's irrigation salinity by diverting water. Damming areas of the river can encourage salinity because these dams are not flushed out, allowing salt, again, to accumulate in these areas. And then there's dryland salinity. So huge amounts of land have been cleared for farming and grazing. Replacement crops and shallow root systems allow water to penetrate down to the water table, causing it to rise. This rising water table brings dissolved salts with it. So if the roots are too short, then they actually cause the water table to rise to reach where the roots are. And then this rising water table brings really, really dissolved salts, which belong underneath, deep into the ground, further up where they don't belong. So it's caused by removing these native plants and by overgrazing or clearing land for non-native plants. When large areas are cleared or replaced with plants with shallow root systems, water can penetrate through the soil, carrying dissolved salts and minerals, which should have been absorbed by plants into the water table instead. As a result, more water reaches the water table, which causes it to rise and carry the dissolved salts. And here is an image of it. And this is something we looked at last year. And of course, it's really important. Now we're looking at, well, this is how the problem occurs, but what can we do to reverse this? Okay, so we need to ensure that we understand the kind of precautions to take and what well, firstly we need to look at what the consequences are to then come up with proper precautions to minimize the effects, because we can't completely get rid of it. Okay, so if we look at the land before clearing, we have the rate of groundwater recharge is very slow. Okay, but shortly after clearing, we start increasing the water table a little bit more. However, as because we get a little bit more drainage, but afterwards, the long-term effect is causing the water table to rise even more. So as the water table rises higher, it brings those salty saline minerals from the groundwater further up into the water table, which won't allow a really not appropriate, won't allow to have a great environment to grow a lot of things. So irrigation salinity. This can be caused by, again, over irrigation. The additional irrigation water causes the underground water table to rise, bringing the salt to the surface. When making the soil inhospitable for growing other things, as I said, when the irrigated areas dries and the underground water table recedes, salt is left on the surface soil. So each time the area is irrigated, the process is completed. So then what kind of precautions can we possibly take? It's become such a concern that communities and governments have come together to combat the problem. Salinity contributes to agricultural losses and environmental damage, which is why it's really important. As we said, we are using, so in order to minimize some problems, depending on whether it is for dryland salinity, or which is the same thing as land clearing, or irrigation. So the precautions that we want to look at are based on both of those issues. So if we look at firstly our land clearing, what we really need to think about, of either of them, what we really need to think about is, well, how can we affect or reverse the issue of the movement of the groundwater which comes from the subsurface to the surface. So we need different strategies. So some of the things, for example, for land clearing, some of the precautions can be replacing the trees that were removed with native vegetation, and leaving trees in paddocks and along the edge of paddocks. These trees will provide shade for stock as well as help reduce erosion. And the use of deep-rooted pasture crops such as lucerne will help to keep the water table lower. So we need things that are deep-rooted, things that actually help keep the salinity down into the groundwater, and covering the catchment areas, and reducing erosion, and using ways to irrigate such as drip irrigation systems. So it doesn't completely flood the area, causing the water table to rise. Another thing is sometimes if there's sites that are really badly damaged, they can be planted with a salt bush or other salt tolerant species. This which will help to remove some of the salt so that less salt tolerant plants will be able to survive when planted in the soil. Okay? And of course, if you do your reading, you'll notice you can also decrease the fallow time, which is the time between harvesting one crop and planting another. This just basically stops that whole entire process of constantly irrigating and making the soil really saline. On larger scales, what can be done include designing and building drainage systems to divert water before it reaches the water table, surface drainage management, so collecting and controlling the water that's entering and leaving an area, which can minimize infiltration, and drawing up water from the water table through bores to keep it at a level below root systems. The saline water drawn up can be collected in evaporative basins or disposed of appropriately. I just want to also speak about irrigation. So it was all put on this. I'll go back here again. So some of the precautions that can be taken may include using alternatives to flood irrigation. Drip irrigation can be through sprinklers, systems, or a trickle, improving the drainage in paddock so they don't sit for extended periods, planting trees around the edges, and of course checking soil types for suitability before water licenses are granted to irrigators. So if you want some more information on areas affected by salinity, check out the internet, go onto the New South Wales Environment Protection Authority and have a look at the environment report. Okay, they often have to release reports quite often, so go out there and have a look. The last dot point that you need for this topic is the one that says it's a case study. So you have to gather data sources, process and present information of a successful rehab program for a salt-affected area, including the origin of the problem, the impact of the salinity problem on the biotic and abiotic environment, the rehabilitation strategy, and the scientific basis for this strategy. So in order to talk about the origins or the impact, you need to talk about where it is, what caused the problem, impact on biotic and abiotic. Remember, abiotic is those factors like soil, water cycle, temperature, climate, and biotic factors are how does it affect the living things in the environment. Not things like temperature, for example, maybe the vegetation in the area or the living things or microbes in the soil. So there are a lot of, I've given you about 3 or 4 different case studies in your worksheet, but there are a lot more, so have a look. I'll put down there a few different other options. Complete the case study and then you would have completed this module successfully.